Welcome back to your very last geometry video of the year, and this is just the final review. I am not going over terminology. I sent you a review sheet home that had most of that on there. If not, you are using your notes since you're at home and I can't stop you. So I'm not going over that. You're also allowed to use your book. I'm going to hit on a couple things that you'll need to work out or understand on there. I will not go over, there's only one proof on there. It is a small one, and we have done it before. Now, I know you don't have all your tests and quizzes. However, I have filled in some of the things on there for you. So these are some things that were either on worksheets that you may or may not have, but you should still have notes on them. But I'm going to hit on them anyways. So I have a couple things on here, and then I'm going to put a few more things on here just to help you out a little bit with your final. Don't forget, you can write all these down and turn them in with your final for extra credit if you would like. So the first thing we're going to talk about is transversals. Now, this is in your book. And then we also did it on the worksheet, and the worksheet was a little bit more cut and dry than the book, so I wrote down the notes just in case you don't have it. I think it's somewhere around like worksheet 23 or something like that. But a transversal is when two lines are cut across by another line, and if they are parallel, which you pretend that mine are, then some certain types of angles occur, and when they occur, you can figure out the measurements of said angles. So there are two separate categories for that. You have congruent angles, which mean they are equal to each other. And then you have supplementary angles, which means two angles that add to 180 degrees. And then I define the types of angles, and I'm going to show you what they are as an example, because you will have to do this on the final. Your transversal may not look the exact same as mine, but you can use this to deduce whatever it is that you need to. So for instance, vertical angles, now we know vertical angles are where like the X happens and the angles that are across from each other. So an example of vertical angles in this transversal would be angles 2 and 3, which means this one and this one, because they're across from each other. So is 1 and 4, so is 5 and 8, so is 6 and 7, which means if you know 6, you can know 7. If you know 2, you can know 3. They are the same, okay? Those are called vertical angles, all right? I'm trying not to mark it up too much, but I do want to show you each type of angle. So the next one is called corresponding angles, which just means this angle fits the same piece on the other, kind of like corresponding parts in triangles, where your tip of your triangle on this one is equal to the tip of the triangle on that one. So corresponding angles would be angle 1 and angle 5, because if this was two separate pictures, 1 is in the same place where 5 is, 2 is in the same place where 6 is, 4 is in the same place where 8 is, and corresponding angles are equal. So it's basically the same angle in the different picture. So 3 and 7, 1 and 5, 4 and 8, okay? Those are also equal. Oh, I don't know what I did with my pink marker. I'm going to write all over myself probably. All right. The next group of congruent angles are called alternate interior angles. Interior meaning on the inside, and this is where you get that Z shape on that review that we did, okay? If I look at this Z shape, alternate means on the opposite sides of the line. So alternate interior would be 4 and 5, because they make the Z, and this is on this side, that's on that side, and 3 and 6, because they're across from each other and they alternate. So they make a Z pattern, all right? And then the last one is alternate exterior angles, which would be like 1 and 8. Now, when we're talking about the inside, we're talking about inside the parallel lines. So these right here. On the outside, we'd have 1 and 2 and 7 and 8. So when we say 1 and 8, and we're looking at our Z pattern, if you had a line up here, our Z would go like that, and 1 and 8 and 2 and 7 would be alternate exterior, and they again are equal. Okay, so that's what congruent angles is, and you just, I believe there are quite a few questions about this, but they all pertain basically to understanding what angle goes with which. So let me try to fix this a little bit so that we can do the other one. I jacked it up a little bit. Alright, so now that we've covered that, let's look at supplementary angles. Supplementary angles are two angles, and their sum, or if you add them, is going to equal 180 degrees, which means 180 degrees is a straight line. So basically any of these that are on a straight line will be supplementary, and if you know one, you can subtract it from 180 to find the other one. So the first part is adjacent angles. Adjacent angles means beside one another. So when I look at this, the example I give is angle 1 plus angle 3. These two are beside each other. They are neighbors. If they had a door right here, they could walk through. That is adjacent, and this is the straight line they're on, so they add to 180. 1 and 2 are also adjacent beside each other. 2 and 4 are adjacent, okay? So it just means beside, and they add to 180. The next one would be same side interior. Now, same side interior means they are not alternate on opposite sides of the line, but they're on the same side and they're inside. So same side interior would be 3 and 5. That means this one and this one. They're on the same side and they're inside. They add to 180. So do 4 and 6. They add to 180. And then the last one in this category would be same side exterior, which again means on the outside, but on the same side of the line. So we're looking at 2 and 8. If you forget that 4 and 6 were there and that was just a straight line, 2 and 8 have to add to 180, and so do 1 and 7. If you can understand those, then you can solve anything that they give you in this. And I believe throughout the pages there's probably like 7 or 8 questions that deal with this. So it's important that you understand that and you have these notes. Okay? The next thing I'm going to talk to you about is the midpoint formula. I think there's only one question about this, and it's a fairly simple formula, but in case you didn't write it down, the formula is x1 plus x2 divided by 2 and y1 plus y2 divided by 2 in order to find your x and y, because this is the coordinate geometry that deals with graphs. So first thing you want to do is identify your ordered pair. X always comes first and then y. Okay, and then I'll switch colors here. You have to assign them 1s and 2s. Now, it doesn't really matter which ones you assign 1s or 2s, but the whole group has to be 1s. If this is x1, that has to be y1. This is x2, that has to be y2. It can't be a 1, 2, 1, 2. All right? Once you do that, you're going to plug them in and solve. You're going to get an x, and you're going to get a y. So when I do my x's, x1 is negative 1, and then I have a plus sign. x2 is negative 5, and I put it in parentheses only because I don't want my plus and negative beside each other. And the 2 is a constant in this formula. So negative 1 plus negative 5 equals negative 6, and then I have a 2 on the bottom. So negative 6 divided by 2 is negative 3. So for my answer, my x is negative 3, and now I need to find my y. Okay, so now I'm going to do the y's, which y1 is 1, y2 is negative 7, and this is over 2. 1 plus negative 7 is negative 6 divided by 2, so we have the same thing, so this one's going to be negative 3, but you still have to write both answers because one's an x and one's a y. Now they're not always the same, they just worked out in this problem. That is the midpoint between these two dots on the graph. So if you graphed that one and you graphed that one, this one would be in the center of those, okay? So that's the basics of the midpoint formula. And the last thing before I erase this board and we go to the next part would be SOHCAHTOA. There's a couple questions about this, and we hit this pretty good. SOHCAHTOA stands for sine equals opposite over hypotenuse, cosine equals adjacent over hypotenuse, and tangent equals opposite over adjacent. And that's what the acronym stands for, so that you know. All right. And all I'm going to do is show you how to set up the problems, because I'm pretty sure that's all they ask you on the final, is understanding how to set up the ratios. So I made a triangle because these deal with right triangles only. And my triangle, BCA or ACB, however you want to say it, they give me some measurements. This angle A is 20 degrees. That's my right angle. I don't know the hypotenuse, which is always across from the right angle. And then this side is 8. So it says list the ratios of A and B. So I need to find the sine, cosine, and tangent of angle A and angle B. So, but I'm only doing the ratios. I'm not actually solving these, okay? I don't know why I wrote tangent before cosine, but whatever. Angle A and angle B. And then I'm going to put the information that I have in there, okay? So sine of angle A, well, first of all, I know that angle A is 20 degrees. So all of those should say 20 degrees on them. So this should be sine of 20 degrees, cosine of 20 degrees, and tangent of 20 degrees equals, and then we're going to put the ratio. All right, and this is where you could get confused. Sine is opposite over a hypotenuse. You must look from the angle that they're asking. If we're asking about angle A, we're looking from its perspective. What side is opposite of angle A? Well, if you put a line in the middle, you draw. So the opposite would be H, and because the 8, because the O comes first, the 8 goes on top. And then the H stands for hypotenuse, which is always across from the right angle, so that would be X. So my ratio there, I'm not leaving myself enough room on here, would be sine of 20 degrees, this is poorly written, equals 8 over X. All right, now the cosine, let me scoot tangent down here. The cosine of angle A is adjacent over hypotenuse. So adjacent means beside. Okay, so we don't know what this side is here. Let me write one just for this purpose, okay? Because I don't want another X in there. Say it's 3. All right. So cosine is adjacent, which means beside, and it can't be the hypotenuse, so beside A would be this 3 side. So 3 goes on top, and then hypotenuse is next, which is X. So cosine of 20 degrees equals 3 over X. That's just how you set the ratio up. The next one would be the tangent of 20 degrees, which is opposite over adjacent. So opposite is 8, and adjacent is 3. Okay, and that's all they're going to ask you to do on the final, and you need to understand that. Now, it depends on what angle you're looking for. Now we're at angle B. We don't really know what angle B is here, and if you couldn't tell, if there was not this angle and you didn't know what it is, you would just say sine of angle B. But because this is a triangle, and triangles add to 180, 90 degrees and 20 degrees, so this one must be 70 degrees in order for it to be 90 and 90, which is 180. So I will say the sine of 70 degrees, the tangent of 70 degrees and the cosine of 70 degrees. Okay, so now we're looking from this angle down, which changes my opposite and adjacent. The hypotenuse never changes, but it changes my opposite and adjacent. For the sine, opposite, this time it would be 3, and the hypotenuse is still x. For the tangent, opposite is 3, and adjacent is now 8. So the tangent, which I still didn't leave myself enough room, would be 3 over 8. And then for my cosine, it would be 8 over x. So I know this is kind of a mess looking right here. So try to listen to my words because I was trying to fit as much on the board as I can. And I'm going to take a short pause and get the second part of the review up there. Okay, the last couple things that I think you might have trouble with or don't remember the formula or how to do them are the interior angle of a polygon and similar figures or a proportion type thing. There are some area, volume, perimeter questions, but that's one of the last things that we learned or went over and reviewed in here, so I'm not going to touch on those, but this has been a while back. So to find the interior angle of a polygon, you need this formula, n minus 2 times 180 degrees divided by n, where n equals the number of sides. So if they give you a shape, whatever shape it is, a duodecagon, a nonagon, an octagon, you need to count the sides if you don't know how many sides it has to find the number of sides. In this picture I have 1, 2, 3, 4, 5, 6. This is a hexagon. Okay, so I have 6 sides. I'm going to put that in there. So I'm going to go 6 minus 2 times 180 degrees all over 6. So 6 minus 2 is 4 times 180 degrees divided by 6. Now 4 times 180, let's see, that's 360 and 360. That should be 720 divided by 6, which should be 120. Yeah. So the answer is the interior angle, these, of a regular means all the sides are the exact same length, is 120 degrees, okay? So just know the number of sides in that formula and you'll be set on that. And the last thing I want to show you is there's going to be a question that looks similar to this, the numbers are different. Find Z in these similar figures. Now this has to do with the proportions section, so you need to set up a proportion here, and what you need to do is take 2 sides of one figure and set the same 2 sides of the other figure equal to each other. For instance, Z and 16, if I put Z on top over 16, I'm just going to use these 2 sides. Then I want to use these 2 sides in this one, okay, and set them equal the same way. If Z went on top, the 8 goes on top. On the bottom of this one, the 20 goes on the bottom. And now I'm going to cross multiply. So I'm going to get 20Z equals whatever 8 times 16 is. That's 128, and of course mine's not going to work out, but you will get a whole number on the one you did. I just made this up. So then you divide by 20, and Z will equal, if I can hit the right numbers, 6.4. So that means this side would be 6.4 if these were similar figures, because the ratios have to stay the same, okay? So just pick a side. Now if you're going to use these 2 sides, then you have to use these 2 sides. But that's a straight up formula. Everything else is either fairly recent, you just had a review page over it, or it's terminology other than the proof, and you have a proof that is kind of similar to the one that you're doing. So use your book, use your notes, write these down for extra credit. Good luck, and turn all your work in by May 11th. Have a good rest of your day, and God bless.